This video is brought to you by our amazing supporters over at Patreon. Not every game benefits from heavy use of systems. In some cases, the player might not notice the systems at play, and you could have just used a randomizer and called it a day. In other cases, the unpredictability of systems might be counter to a tight narrative or a stringent set of mechanics in your game. However, there are some genres and mechanics in games that frequently use and thrive with systems, which can give you a sense of whether your game fits that description. Simulations. Systems are ultimately emulating some phenomenon through data and algorithms, so simulation games make heavy use of systems in their operation. This can refer to both realistic simulators like flight and truck simulators, or to more abstracted or fantastical scenarios like SimCity or Dwarf Fortress. Typically, the effect is even better with larger strategic sims, because with a more zoomed out view, patterns emerge and interactions of systems become more apparent. Many of these strategic sims also give an illusion of a lack of control, because you lose control of individual units, but you still control the organization as a whole. There are plenty of examples of these in the logs of games like Dwarf Fortress. In fact, you still retain all the control. You're ultimately telling units what they can and cannot do in the grand scheme. It just happens on their schedule and with their pathfinding. On the flip side of all this, the result of this loss of control phenomenon is that you spend more time watching your units, sometimes with exasperation, but you see the system in action. Stealth games. Stealth games are, in my opinion, one of the best candidates for systemic game design. The very design starts with a default automated state, whether it's the patrols of guards, or a web of monitoring systems, or other security across the level. At minimum, this typically implements some line of sight and AI systems to detect and react to the player. Then we layer on player interaction. Straight out of our systemic game definition, players must interact with and possibly manipulate these systems in order to reach their goal. At their most basic, this just involves avoiding being seen by observing patterns and using gaps in coverage. As systems are layered on, however, players can create distractions, take out sentries, or even change the level on a larger scale to achieve their goals. Grids and discrete graphs. This one is more of a way to make systemic design easier, but it's valid nonetheless. Computers tend to think in discrete units, or at least do so more simply than when they deal in gray areas and continuous spectrums of space or data. As a result, it's typically easier to set up a system that works within a graph of discrete nodes, where neighbors can be checked to determine evolving effects. This will often take the shape of a grid, with orthogonal nodes in 2 dimensions, but could technically take on any shape you choose. An additional benefit of this sort of discrete approach is that the delineation between nodes and states becomes more visible to the player as well, which makes the effect of systems easier to recognize and appreciate. Open world games. Whereas the last 3 examples are easier to add systems into, this final example tends to really benefit from the addition of systems into it. Open-world games require a great deal of content to fill their space and make the player feel like they're in a living, dynamic world. Systems can be a huge boon to this. A handful of procedural events that respond to systems can feel dynamically different depending on which state the systems are in at the time. For example, a vampire encounter could be very different if it's night or day, or if there's a river or a building nearby. Even if you're populating your open world with handcrafted scenarios, systems can make this easier. For example, in Breath of the Wild, there is one section, Eventide Island, that turns the entire experience on its head by stripping you of the equipment that you've collected. So in turn, you must utilize the systems of the game to build up a new arsenal, and ultimately defeat an enemy who would be challenging with your normal loadout. None of the encounters in this area are different from what you experience elsewhere in the world, but because the state of the game has been changed, the encounters feel very different. With systems, you can add, remove, and manipulate different modules of your systems to create a wide variety of experiences with relative ease. As with the last section, this is not an exhaustive list of game styles that can work well with systemic design. These examples do tend to bubble up to the top though, so if you're designing a game in one or more of these styles, it might be worth thinking about how systems might improve your game experience. One thing I specifically didn't talk about in this part was the idea of procedural generation, which is also systemic, but exists outside of the scope of systemic game design. I'll dive into that topic in a future video. In the meantime, thanks for watching, and I'll see you next time.